Hi, my name's Robert Steltman. Today I'm going to show you how to use some of the site tools, specifically street tools, on how you can do your streets. Instead of using templates and cross sections, we're going to do it all with 3D polylines. After selecting multiple 3D polylines by delta, we have a library of templates that we can use that will give us each a number of offset 3D polylines. Each value is relative to the center line, so this one is going to be 4.65 units from center line, and it's going to be 0.1 higher than this profile. All polylines will go on the layer 3D PL. On this one, we're going to go right from the start of the alignment to the end, and we're going to put a vertex every 5 units. Now for our road with the cul-de-sac and the elbow, we have to first draw it in 2D, and then we have to move the 2D lines into 3D. We're going to select a file called 201-1, and this gives us offsets horizontally and from center line and a width. If there's a width, it will draw 2 lines. If there's a 0 width or diameter, it will only draw the 1 line. The previous routine defined where we want the offsets located. This one tells us, the previous one gave us distance. This one will give us the location, and we just go OK, and we'll draw these lines on our plan. Now we want to have the cul-de-sac or the elbow or knuckle concentric to the right-of-way. So we're going to set the center of the right-of-way. We'll make it the center point concentric to this polyline. We'll put a 17-unit bulb with 12-meter returns. We eyeball close where we want those returns to go and opposite side of the bulb, and it will draw those polylines for us. Similar for the cul-de-sac, we're going to put 0 offset. This will be the center of the bulb. We'll give it a 15-unit radius, 6-meter unit returns, eyeball close, and there's a returns done. Using AutoCAD, we can break the right gutter line at the end of the bulb. We also have to join the left gutter line at the end of the elbow using the pedit grips command, and then we'll go pedit and join the two. We're going to do multiple polylines by grade, but this time we're going to use a different set of parameters. These points are all relative to the previous point. We're going to have 2% crossfall, and then we're going to put in a 15-centimeter curb and going up at 1:1. This time we're going to start at station +5, and we're going to the end, and again we're having vertexes every 5 units. We have to make sure we select the left gutter and the right gutter, and you'll see the offsets have been grayed out. Zoom in on the intersection. We're going to put a 10-unit radius with a we're going to go before the curb return starts 10 units and past the curb return another 10 units, and we're going to have 1 unit chord lengths. And zoom in, select the intersection of the gutter lines, select the 2 polylines that go into the gutter line. It comes back, and it may or may not be correctly. If it is correct, you just go enter. Up comes a dialog box showing what it looks like now. We're going to put in a vertical curve over the whole return. We're going to go grades. We're going to go up at 8 and down at 2, and we're going to put a vertical curve in, and maybe we'll put in a 20-unit curve. Go OK. OK, this is what it's going to look like. We'll also plot the detail and label the quarter points. Go OK. Select the profile location. Here's the details. Here's a detail of our profile. Then it prompts you to pick the intersection of the backer curve. Again, you select the two polylines, flip the arc no, and there's your curve returns done in 3D. Do the other side, clean up the intersection, and your intersection is all cleaned up. Just another example of how Steltman software can help you use LDD more productively with fewer errors.